Hello everyone, welcome to my video. Okay, let me just enlarge this. Yeah, okay. So here I am, and this time I am come up with the new project, and that is AI-based credit card fraud detection system. So the highlights are, as you can see on the screen on the presentation window, that first highlight is alert generation via ANN model, means AI model. So that is the AI model uh, we were using before also for previous projects, but this time we have trained it for credit card transactions. Okay, so watch the let's see the second point of second highlight pointed is that AI code modification at alert level cumulative value. So this is the approach. For this credit card fraud detection system that I have initially trained the model, AN model, and then I will generate the alerts based on cumulative value. And why cumulative value? Uh, I will tell you. Just give me a moment. Okay, so yeah. So as you can see, you know, the cumulative value is a sum of the values. So you can see here there are multiple transactions for this card number ending with 4230, and there is a single transaction for this number ending with 6520. So what is the benefit of cumulative value, generating the alerts on cumulative value, that it can check for both single and multiple transactions. So if you can see that for these much transaction, if I put a threshold of 67,000, then the sum of this is 67,000, as you can see here. So if the threshold is 67,000 or greater than 67,000, so this will fire also as the sum up becomes this, and the single transaction goes for 67,000 and above, then also it will fire. So what the thing is that the logic behind that is a single large transaction cannot be fraudulent because anyone can use, I mean, for any much amount. But if a card is being used repeatedly in a short span of time, the possibility and the indication is that it might be a fraudulent activity. So like this one here, multiple transactions are there. So what I have done is I have named the alert as P1B for multiple transaction cumulative amount, and then for single transaction cumulative amount P1A. So this is I have done. So I have explained it now in a very easy manner. So this covers the third point also, high level engineering approach for P1A and P1B alerts. Okay. So the next point is that card wise AI system barring report will be done. This is the same way that we have done for the our previous project also. I will show you again. Let me show you. See here that the card number and amount will be generated in the end of every time interval of this alert, I mean script level. So the card number and the card all the card numbers that are being action has been taken by the system, and the corresponding amount will be there in the barring report. Okay. Okay, so yeah, we have discussed these points. Also, I told you that this cumulative value point because it will help in reducing the false positives. Now let's move to the next slide. Okay, so yeah, so this is the AI based response system that I have designed. And what is the feature of response system? That the transactions alert will with generative info will be there which will be having the fraud probability and fraud disposition. As earlier we were doing, same here we will doing for these for the transactions. Then it will assist the on-duty analyst with AI-based recommendation and reducing the workload up to 70%. Same generates alert info and fraud probability. So we'll assist on the critical fraud scenario and will take action on behalf of analyst. I mean the automated barring will be happening on the fraud transaction as well. I mean on particularly on fraud transaction only. So this is the AI alerts updation I want to discuss. So we will generating the fraud probability firstly per transaction. Okay. So it will be happening transaction wise only. As you can see, if I show you like this is a combined alert. But what happening is, like this one probability 0.99, I mean 99%, or for this for this transaction and for this card number 0.51, 51%. So this much only for every transaction there will be a particular fraud probability will be generated for that. Okay. And similarly, then we will group these transactions. So the only the fraudulent transactions will be taken into account and will be clubbed under one single card number, and the single alert will be generated. Similarly, you can see here the multiple transaction are there, but this all transaction will come up only into single alert with the card number for this card number. And similarly, if there is single transaction, the alert will fire for this card number. But you can see here the we are we're taking the fraud flag as true. It means only fraud transaction. So this 51% probability transaction will not be happening. Only those transactions which are categorized as fraudulent. And the fraudulent probability that I have given is minimum of 90% and greater. All right, because I don't want unnecessary records to transactions to be participate. So I need a very high genuine data, genuine transactions to happen. That's why. So another point is third point is P1A and P1B alert levels are prioritized for single and multiple transaction. I elaborated also for, like, single transaction the P1A alert will fire, and for multiple transaction P1B alert will fire. It will help segregate the you know intensity so that analysts can choose between these to work upon as per their SOP and SLA, to work upon firstly on which alert. So the barring mechanism for saving revenue loss with very highly trained ANN model and extremely high testing and training accuracies. So you can see here in this slide in below these all this point here is the training accuracy 99% something, and testing accuracy is also 99.45%. So the NN model has been trained on extremely high testing and training accuracies are achieved. I will tell you how. Firstly, if you want to make your credit card system detection fraud detection system, you can simply go to website. There you can search for credit card fraud detection data sets, and I have used this one kaggle.com. And you can see here, if I click this site, it will open the page, and you can see here there are multiple data sets if you click on these data sets. But here is the data set particularly that I used, credit card fraud detection. So the same file I have used. So what is it is it is what we will I will just read what is written over here. The dataset contains transactions made by credit cards in September 2013 by European cardholders. This dataset present transactions that occurred in 2 days. So you can see here they are stating that 492 are fraud records out of this much transaction. 284 807 transaction. So I will show you, because let me read this also. It contains only numerical input variables which are result of a PCA transformation. Principal component analysis is done because they don't want to share the original feature and more background information. So that's why the column names are being transformed into V1, V2 till V28. And the only features which have not been transferred to PC are time and amount. The amount is there, I will show you. And time is, what is the time? You can see here they have elaborated number of seconds elapsed between this transaction and the first transaction. So for every transaction, the time will contain the time between the last transaction and this the current transaction. Okay, so let me show you the data set also. Okay. Okay, so here you can see that the same CSV file is there. I have already opened because it's a very large file. So this is the file, and you can see here the time and amount column along with this V1 till V8 columns as was elaborated in the website. So let me show you the website also. It is stating, I mean, that it has 492 for fraud out of 2,84,000 something transactions. Let me show you. I am not making this up. This is the same file that I downloaded. You can download also. And if I check the fraud cases denoted by one, you can see here in the left side of the screen below 492. Even if I do this, you can see here count is 492 for fraud cases. So same CSV file, the NN model will be trained upon, but there is a great advancement I have done. Out of these records, what I have done is I have, out of these 2,84,000 records, what I have done is I have made a synthetic data. Let me show you. Let me close this. Okay. So if I show you synthetic data I have created for training the ANN model. So you can see here the path is there for that particular credit card CSV file, and we will generate the synthetic data, and synthetic data file is here. You can see here in the last what I have saved synthetic data dot underscore data dot CSV. So same file I have opened. It's a very large file. That's why I have opened it before because it will hang the system. So you can see here what is the count. Now the count becomes uh, 5,68,000 something. Okay, and another thing I have done is, I have added card numbers also, because because these card numbers will be added on the new incoming data as well. But this is a training data. We will drop this and at the time of training. But for incoming record, we need the card numbers. That's why we will add the card numbers on incoming record file. So that's why I have made synthetic data, because I already told you last time also. This time I have used smart technique to add the transaction. We can use generative AI model as well, but smart has also done the job for us. You can see here I have imported smart library, and then I have used sampling strategy minority level and created a synthetic data using smart, so that the data is more. So what happened, the ANN model will learn very easily and very effectively. That's why I told you the accuracies are so much high. Training accuracy is 99 and 0.44, and the testing accuracy I will show you in the code also. The configuration code that is here only, you can see here the whole code the dataset has been trained upon. And same, the ANN model has learned as per running on different epochs, and when the accuracy is higher, so it will stop at that moment. And you can see here Testing and training increase same what I pasted over that PPT. So okay, so that proves my point of the synthetic data. And now what will happen? What will happen is that let me close this file first. This will hang the system. Okay. Okay. So yeah, I have closed that file, and this is the incoming record file for the transactions that I have made. Let me just format this to showing purpose. Okay. So yeah. So similarly, I have added card numbers, and also the amount have been changed. I mean, the random card numbers and random amount has been, taken into place. Uh, Let me show you. Yeah. So here you can see here I have put random amount and also the random card numbers are there and saved as credit card with card numbers.csv. Same file is there. So we will process this file and we will generate alerts. We will see how they will breach the alerts. I already tell you for each transaction like this record, each transaction ANN will make a fraud probability. And if it exceeds or equal to 90, then the alert will be generated single transaction wise or multiple transaction wise for the same card number. So I will close it now. It's a very big file. It will hang the system. Okay, so we are done with the PPT part. Also, I want to explain one thing, the hypothesis testing I have done. So, I believe it's a very interesting topic. Let me elaborate to you, explain you. Okay, so as we were discussing about hypothesis testing, okay, so what hypothesis testing is, I believe everybody knows it. I mean, generally people knows it. What is it? That it is a statistical method to draw conclusion about population based on sample data. Population is not about the country's population. It is a parameter. You can see here hypothesis testing. You can see on the presentation window. Start with hypothesis about a population parameter. Collect sample information. Then reject. Do not reject hypothesis. So, in a simple scenario, in a general scenario, I will tell you that will give you a brief overview and idea that whenever a judge, whenever a judge comes to hear the case and convict goes for the hearing, so judge has this initial null hypothesis that the convict is innocent, and then case by case I mean, how the case progress, and then if judge comes to know, no, I was wrong. The convict is a culprit. So that means it is this is alternate hypothesis. So there is two hypotheses now, as you can understand, null hypothesis and an alternate hypothesis. So similarly, okay. So similarly, in our case, we will do hypothesis testing. So what will be our null hypothesis? I will show you data because data I already told you that is being transformed because of the privacy purposes. They have transformed the data, so we don't know all these columns have relevant information about location, transaction, date, and time, but we don't we cannot check because they have transformed. Just amount is there and the time between the last and current transactions is there. So only amount is the thing that we can use this in hypothesis testing. So yeah. So what will be the scenario? I will show you. I told you already that there is null hypothesis and there is alternate. So what we are taking as null hypothesis is that the distribution of the variable are the same for fraudulent and non-fraudulent transaction. Variable is our column amount for this use case. Okay, so yeah, so here is the amount column. Okay, so yeah, it means that all other, I told you all other columns are not available, so only we can do hypothesis on amount. So what is our null hypothesis? That we are believing, we are making assumption that the distribution of the transaction amount are same from for fraudulent and non fraudulent transaction. It means we are having the assumption that any amount can be fraudulent and any amount can be non fraudulent. I mean, a $10,000 transaction will be legal if it is done by customer, and the $10,000 can be illegal or fraud when done by the fraudster. Okay, so yeah, so our assumption is that amount is not contributing towards the transaction to be fraud or not fraud. So this becomes the null hypothesis. And similarly, then the alternate hypothesis becomes that it is contributing. So we will test it now. Firstly, I have, you can see here the path. I have put the synthetic data that I have trained the model. So we will use it, and I will just hit the run button of this code. And if the p-value, as you can see, is less than 5%, 0.05%, it means 5%, then we can reject the null hypothesis. If it is less than 5%, oh, what a beauty. Yeah, results are there. P-value is how much? 0.47 something, means 47%. So it means if it is not less than 0.5, you know so we don't have to reject the null hypothesis. Now we have to accept the null hypothesis. So yeah, it means that our assumption was right. So what's happening is, amount of any transaction is not contributing the towards the fraud versus not fraud. It means it don't have any relevance to the fraud cases and even to not fraud cases, this amount. So now you got my point. Also, I will run this code for the the new record file also. Let me run this similarly. It is just running. You can see here this bar is showing. Okay, so the p value is 40%. Again, even in the new record coming file, it proves that the null hypothesis is right. The distribution of the amount of transaction are the same for fraudulent or non-fraudulent transaction. So you can test any samples you can take, and then you can make a assumption, and you can make a assumption that you will treat it as null hypothesis. And if it is it is not correct, then the alternate hypothesis will prevail. So similarly, these surveys, I mean these exit polls are done. And so but the main thing is that the data they have gathered, they have sampled, it should be correct. So, okay, so this was the interesting topic that I have discussed with you. I believe I was able to convey. We will go. Okay, so now this is the script that I have to run now. You can see here it already have this model file that I have made uh, by via training the ANN model, and then the file incoming record of CSV file that I have made with random amounts and random card numbers. Now we will just run this code and we will wait to generate the alerts. So you can see here the bar in this, you can see the this time frame, the bar is going on, and so the code is running, and we will wait for the alerts. Okay, so as we can see now that code is running and has processed the transactions, and you can see here, the NN model has done predictions, and you can see, wow, what a beauty that the transactions, single transaction, multiple transaction. I told you the alerts are generated based on the cumulative thresholds, and okay. So the threshold I give it for cumulative value for this incoming record file is $200. Okay, we will now go to the email window and okay. So yeah, wow, what a beauty! You can see here, a lot of alert around about 54 alerts have been fired. So if I click this, you can see here, fraud alert, AI generated P1A. P1A means single transaction. It is written over there, cumulative amount. And I told you $200 was the threshold. So in the single alert, more than $200 amount and fraud probability, I told you already the fraud transactions we are monitoring over 90. So already the probability is 99%. Oh my god. I mean, how so what is the AI based system suspicion of the alert is fraud? For precaution, the card number have been temporarily blocked. Here are the details of the record. So wow, you can see the probability is so much high that the because of synthetic data, ANN model is able to make these probabilities and the synthetic data was 5 lakh something, and if it is giving 99 probability, it means that it has found it is found a very high transaction, I mean similarity with the fraud records. You can see that already amount, if it left amount and time, there were 28 columns. So if the columns are there, features are there, I mean it will be quite good for the model to make comparisons. So you can see here also 99%. So I told you that N is the AI is the best thing that I have done to the humanity and to in our particular use cases. So it is giving very highly accurate accuracy wise results. So you can see here similarly the AI based disposition is fraud, and the precaution, the card number had temporarily blocked. Let's see for multiple transaction as well. See here are the P1B multiple transaction. Oh wow. So yeah, fraud alert, AI generated P1B multiple transaction for this card number. Dear user, this in this alert, this card number has been found in suspected transaction of cumulative amount of 418. Okay, let's check this. If we add this up, it will become 418. And the AI based disposition is fraud. For precaution, the card number have been temporarily blocked. So see, I told the power of cumulative uh, amount or cumulative value that we the logics we have put. Okay, so every record is fraud because we are taking only fraud record, but the fraud probability is very high because AI and distinguishing the records in a very very highly accuracy manner. So see, if I click this multiple transaction, you can see here also 522 160 104. If we add this, it becomes 688. Okay, so this I want to show. There are this is the simple rule I have made, but I have segregated into single and multiple transaction. It will serve the purpose because this is some engineering that I have done. But similarly, there are n number of scenarios. I have not worked on bank industry, but I will tell you that this was in banks also they use velocity rule also for amount and for the this time as well. If one transaction happens from India, another transaction happening from UK, US within a small time frame, 1 hour or something. So it's obvious that you cannot, someone cannot fly because the location history is there. If you make a transaction through POS or ATMs, so we can configure, and then also barring can place if banks wants to place. So lastly, I will show you that for all these 54 alerts, but I told you that similarly AI card wise cumulative amount barring report will be done. So here you can see that will capture the script ran. At the end of the script, it will check for the credit card numbers and the respective amount, and it will publish it. It will be easy for on duty analysts or managers to just make a log of that. So guys, now Akhil Singh Rawat, this is Akhil Singh Rawat signing off. As it was a very hectic project, and I somehow I was able to pull up, because I have not worked on the credit card transaction fraud, but I want to do it because these is related to something I have done and I want to know what the fraud industry and fraud vendors are doing to track the fraud behavior. So guys, have fun, take care. Now I am signing off. Okay, bye bye.